So hello everyone, in this video we'll be solving another LeetCode problem and the problem name is separate squares part 1. So you are given a 2D integers array squares. Each square of I represents the coordinates of that particular square and the length of or the side of that square. So xi, yi, l of I. So these are the coordinates and this is the side of the square, which represents the coordinate of the bottom left point. So basically these coordinates are nothing but bottom left coordinates of that particular square. So let's say if a square is given, so in this squares array its bottom left is given and its side is given. So with the help of that we can get all of the other coordinates as well. So yeah, basically the the bottom left point and the side length of the square which is parallel to x-axis, which is given to us. Now we need to find the minimum y coordinate value of horizontal line such that the total area of the squares above the line should be equal to the total area of the squares below the line, and answer within 10 raised to the power minus 5 of the actual answer will be accepted. And then they have given the note that squares may overlap, so overlapping squares should be counted multiple number of times. So this actually solves the problem of overlapping squares. So let's say if two squares are overlapping, so in this case we will consider the area 1 as this and area 2 as this. So we don't need to worry about the overlapping part. We can just count it multiple number of times in the multiple squares. So this actually solves the problem of overlapping squares. So we don't need to worry about the overlapping thing. So we can just focus on the getting the lowest y coordinate, which can say that okay, the area above my points and area below my point is equal. Now we need to get in the precision of 10 raised to the power minus 5. That means we don't need to return here any integer value. We need to return a value something like this. Let's say 1.00004. So up to 5 decimal places you need to have the precision of whatever line you choose. So this is what the question is saying. So you just need to find the minimum y line or the the line which is parallel to the x-axis such that it can divide the entire 2D plane such that the area above area of the squares above that line and area of the squares below that line are equal. So let us understand with the help of this first example what the question is saying. So in this case the minimum y line here is y equal to 1. So you can see there is one square above it, so its area would be like area 1, and there is one square below it, its area would be like, let's say, area 2. This is area 1. So in this case the area above and area below will be equal, so that's why this is the minimum y line. So we will be returning y equal to 1 as the minimum line such that the area above or all the squares area above it and below it are equal. So what can be the naive way of doing this particular thing? So naive way can be like just check each and every line. Let's say, let me choose some different pen. So you can start from 0, then you can start just make your line above, and for each and every line check what is the area above and area below. So whatever lines gives you the equal area above and below, just return that line. So it will take if you look at the constraints, the y can be as max as 10e9. So 1e9 values we need to check, and actually we don't need to check 1e9 because if we are checking a line at say which is line equal to 2, y equal to 2, so the next value won't be 3, the next value will be 2.00001 because we need to have the precision of 10 raised to power minus 5. So we need to go into decimal parts. So we need to have the precision of 10 raised to the power minus 5. So these many lines plus the precision of 10 raised to the power minus 5. So we can say that our complexity will be 1e5 cross 1e9, and this is just for checking the lines. We haven't calculated the area of the squares. We will also calculate the square area, right? So sorry for that. Yes. So we will also calculate the square area. So for that we need to iterate over each and every square for each and every line that we are checking. So how many squares can we need to check? So in the worst case we can have squares value as 5 cross 1e4. So our total time complexity in this linear search will become 5 cross 1e4 cross 1e9 cross 1e5, and I don't need to tell you that this will give TLE, because this will obviously give you the TLE, and this solution will not work. So linear solution will not work here. So if the linear solution is not work, can we look for the binary search approach? Binary search on answer. Binary search on answer. Now for binary search on answer, we need to have some kind of monotonic condition. Let's say if something is coming like false, 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 then after that everything should be right. There shouldn't be anything false again. So it should have a monotonic character. So can we see a monotonic character here? Actually yes. So let's say squares are given to us like this. Now this is the 2D plane which is given to us, and let's say our currently the mid value is here. So in the binary search we calculate low, high and mid. So this is the mid value, the green line. Now we will calculate the area above this green line and area below this green line. Now if the area above this green line is larger than the area below this green line, so we can say that okay, we need to shift this green line upward so that we can have balance between the area above that and area below that. Similarly, if we had other way around, if the mid value was here, if the mid line was here, so in this case we can see that area above is lesser than the area below it. So in this case we need to move this middle line below it. So we can simply say that yes, the monotonic character works here, and instead of checking if our area above and below are equal, we can say either of that, either area below is larger or area above the midline is larger. So we can check if the area below is larger than what? Larger than the above area. So if the area below is larger than the above area, so in this case the below area is larger, so we need to shrink we need to pull our middle value to lower values. So in this case we will say our high should be coming to the mid value, because that's when our mid value will become more lower. So in this case we'll say our high value should be equal to mid value. Otherwise, if the above area is larger than the below area, so in that case what we will do, we need to move our mid pointer to above. We need to shift our mid line to greater value. So in that case we can say okay, our low should be coming to mid value, because that is when our mid value will go upwards. So with these conditions we can move our binary search pointers. So obviously in the binary search we just need to play with the low, mid and high pointers. So with these conditions, if the area above is larger, area below is larger, with this condition we can play with the mid pointers and we can get our answer. So this is how we'll be applying the binary search. Now what will be the value of low and high? So low will be 0, and if you look at the constraints say that our y can be as big as 1e9 and our side length can be as big as 1e9. So in the worst condition, what can be the last point that we can encounter? So it says that our bottom left point will be 1e9 in the worst case. So from the bottom left, if we draw a side length of 1e9, so our square would look something like this: 1e9, here also 1e9, 1e9 and 1e9. So this will be the worst condition. So this is what? 1e9 plus 1e9. So it will be 2e9. So our high value can be as max as 2e9. So 1e9 plus 1e9. So this gives us 2e9. So we will keep our high value to be 2e9. So low will be 0 and high will be 2e9. Now obviously you don't need to keep such a high value 2e9. You can just check for a current 2D plane what is the maximum point that we get, so that we can prune the other conditions or the other values. But yeah, 2e9 will also work pretty well. So I will keep low value to be 0 and high value to be 2e9, but instead of 2e9 you can also change your high value depending on what is the maximum point you can get in the current 2D grid. So in the current 2D grid, let's say there are only 2 squares. So the last point is, let's say 5. So in that case you just need to put your high value to be 5. you don't need to take 2e9. So yeah, but I'll keep it 2e9 so that I don't need to calculate in each and every 2D grid what is the what you can say, what can be the topmost value or what can be the highest value possible. So in that case I am putting my high value to be 2e9. So we have checked, okay, this is how we'll be applying the binary search and all that, but how will we calculate the area of the squares? So for the area of the squares, let's say let me choose some different color pen. So yeah, we can just take our squares to be like this, and yeah, this is the 2D plane in which we are iterating. So let's say our mid value is currently here. So yes, we need to calculate the area below it and area above it, and we need to check if the below area is larger than the above area or not. So how will we find the areas below part and the above part? So we will take top point and the bottom point. If the top point is lesser than this middle line, that means obviously this square is coming in the lower part. And if some bottom point is coming above this middle line, then obviously this square is coming in the upper part. So with this, we can, for every square we will calculate, we will get its top point and the bottom point. And if the bottom point is coming greater than or equal to the mid part, that means this square is in the above part. And if the top value is lesser than equal to the middle part, that means this square is coming in the lower part. But what if we have some scenario like this? So let me just draw this again. So let's say we have squares like this, and currently our mid value is here, somewhere here. So in this case, this part should be coming in the lower area and this part should be coming in the above area. So how will we calculate this? We already have the bottom point and the top point. So this is the top point and we have the bottom point, because we are checking the condition based on this top and bottom point. So from this mid value, the difference between mid and bottom will give you this, right? So difference between mid and bottom will give you this particular length with yellow. So to calculate the area, which is this, we can just multiply this mid minus bottom multiply by side length, because side length will remain as it is. So side. So we will calculate the below area. So below area in this case will be what? Mid minus bottom multiplied by the side length which we have, which is given in the squares array, the 2D array which is provided to us in the question. So this is how we'll be calculating the below area. And how will we calculate the above area? Simple. We have the topmost point and we have the middle point. So we can get this particular length as top minus mid, and we can just multiply it by side. So this is side. So we will get this particular area. So top minus mid multiplied by side. So this will give us the above area and this will give us the below area. So this is how we'll be doing the binary search, and also will not be applying the traditional binary search which we have something like this. So while low is less than high, then compute the mid value and do the binary search. So we will not apply this traditional binary search, because here we don't have a normal binary search. We have binary search with precision. So we will be having one precision value which is nothing but given in the question as 1e minus 5. So now we will change our binary search condition in the while loop from low less than high to high minus low is greater than precision. So this condition will change from the traditional binary search, and then we can just do the normal thing that we were doing. So instead of low less than high, we will write this condition for binary search with precision. So yes, let us see the code now. So yes, this is the code. First we have declared the low value and the high value. Obviously you can change your high value to the current scenario of the squares, so that you don't need to take a very high value. But yeah, this value is also fair enough. Then we have declared the precision value, and this is the binary search condition that we were talking about. So this is not the traditional binary search. We are changing this condition as high minus low greater than precision. And yeah, we are just like calculating the mid value, low plus high divided by 2. Then we are checking the condition, how will be able to go towards the left part or towards the right part. So if the below area is greater than the above area, so if the below area is greater, that means we need to shrink our if we need to move our mid value to below. So for that we are making a high equal to mid. Otherwise, if the lower area is not greater than the above area, that means the above area is greater, that means we need to what you can say, move our mid pointer to above value. So that's why we are doing low equal to mid. And how we are calculating the areas of square? So this is that function. So we are declaring two variables, below area and the above area, and then we are iterating on the squares. So first we are getting the bottom y coordinate, which is given to us as the square value. So square of 0 tells us the x coordinate, and square of 1 will give us the y coordinate. So this will give us the bottom y coordinate. Side is nothing but the second value of square, so squares of I comma 2. And the top y we can calculate by just, if you have the bottom point and if you have the side value, so we can just calculate the top point like this, just bottom y plus side. So this is what we are doing, bottom y plus side. Then we are calculating the area below this midline and area above this midline. So how we can say that a particular square is coming in the below line, below area or the above area? Simply we have seen the scenario. So we will check each and every square's top point and the below point. So if the top point is is lesser than equal to mid, that means that particular square is in the below area. So we will just add that area into the below area part. And if some square's bottom point is coming above this middle line, that means that square is coming in the above area. So we will add that square's area into the above area. Otherwise, we can have one more scenario in which our midline is looking something like this. So for this square, we need to have this as the below area and this as the above area. So for that, what we are doing, we are again calculating the new bottom and top points, which is nothing but the mid minus bottom y. So mid minus bottom y. So this will give us this side length, and we will multiply by whatever side we have. So bottom multiplied by side will give us this particular area. And similarly, the top y will be coming as top y minus mid. So top y minus mid. So this will give us this side length, and this side we already have with us. So to get this above area, just multiply side with this particular value. So this value is top and multiply by side. So this is how we'll be getting the above area and the below area. In the end, we are just checking if the below area is greater than the above area or not, greater than equal to above area or not. If it is true, then based on that we'll be just moving our high and mid value ahead, and in the end we are just returning the low. So I hope you understand this particular solution. Thank you for watching.